So hello everyone, in today's video we are going to see the concept of trees. We are going to understand how trees are executed in data structure. What are the basic terminologies that are used? These are very important terminologies because as and when you work with trees in data structure, these terminologies will be used for your implementation of the concepts. So let's try to understand each step by step. So we move on to the concept of trees. The very first point that you see on the screen is non-linear data structure in C. We have seen a lot of data structures. We started with the concept of array, and then we moved to stack. We had queue, linked list, right? All of these were linear data structures. Data was stored linearly in this data structure. But here in trees, the concept of trees says that non-linear data structure. That means here in this case, data will not be stored linearly in a sequence. So how is this data stored? Nodes connected hierarchically. So here data is connected not sequentially but in a level hierarchy. Okay, so as you can see here, I have drawn a structural representation of tree, which is very easy to understand. We go step by step to understand this. So this complete structure is your tree. Now let's break it down into parts or components for us to understand. Okay, the very first pointer is root. So your tree starts with a root node. Can you see this? All these circles that you see are your nodes. Okay, and the topmost node is always your root. So that is what is mentioned over here. Okay, all the nodes are connected with the help of edges. Okay, all the nodes are connected with the help of edges. The next point we say is parent. What is a parent node? Any node which has subnodes, that is child nodes, is going to be a parent node. So in this case, this is your root node, right, which is a parent to B, C and E. Okay, B is a parent node to D and G. Similarly, C is the parent node to F. So any node which has subnodes connected to it, that node is called as your parent node. So you have your parent node. Next is your child node. All the subnodes connected to one particular node. Okay. So in this case, B, C, E are child nodes to A. A is parent to B, C, E. B, C, E are child nodes to A. Similarly, D and G are child nodes to B. F is child node to C and so on. Child node. Then we have siblings. So as you can see, so the nodes which have same parent, are siblings. The next part is leaf node. Now what are these leaf nodes? Leaf nodes are the end nodes which do not have any child node. So in this case, D, G, F, H, L, K, M. These nodes have no child nodes. So that is called as leaf nodes. Next you have is internal node. Now what is this internal node concept? Here, internal node is going to have any node which has one child node is an internal node. So in this case, even a root is going to be an internal node because it is a root node. Why? Because it is the topmost node and there are nodes connected to it. And if even one node is connected to that node, we call it as an internal node. Okay, but except leaf nodes. Why except leaf nodes? Because leaf nodes will not have any child node. That's why leaf nodes are never internal nodes. Internal nodes are nodes which has one child node. At least one, you can say. With that, external node are node which has no child. So in this case, whichever node has no child, that is going to be your external node. Okay, so your leaf nodes, as you can see, they have no children, so they are your external nodes. The next is we have path. Now path, as we already know, when we are connecting two nodes together, right, this particular thing is your path. Okay, a path is something which connects two nodes together. So path. Then you have is level of trees. What is level of tree? Now level of tree is something that we calculate. Now if you can see in the diagram also, I have mentioned levels over here. Okay, starting from the root node, I have level 0. The next set of nodes that are connected to the root node, that is level 1. Then their child nodes is going to be level 2. If there are more child nodes, the level goes on increasing. So level of a tree are number of steps. These are the steps. That is your level. Next you have is depth of a tree. Okay, depth of a tree. Depth of a tree is called as length from the root till the particular node. Now suppose in this case I am trying to reach to D node. So its depth would be what? From A to B and from B to D. That is the depth. Depth talks about length from root to the particular node. Number of steps talks about from the root till the last level that is there. Depth talks about from the root till the particular node. Okay, in this case if I talk about M, we'll take the last node itself. If we talk about depth of this, it starts from A to E, E to I, sorry, E to J and J to M. That is the depth. Are you getting it? With that, height of the tree, that is the maximum number of edges that are connected. The number of edges, these are the edges. Maximum number of edges is going to talk about the height of the tree. Okay, so these are the important terminologies that fall into the concept of trees. Go through them, because in your examination they would ask you concepts based on, you know, explaining these terminologies, or they might ask you to find or calculate something based on these terminologies. So if these concepts are clear, it will be much more easier for you to implement it.